changes, but we realize there's no change. It just keeps going this same way forever. So what do? We just plot one point. Start at -2 on to infinity. Simple dimple. And which direction does the function go? Does it increase or stay constant? It actually increases. See, we can tell because it's going up forever. It's not going straight forever, but up. That's how we can determine if it's constant or not. Question number 4. We got a little trickier one. Here we have what I see is 2 different plots, or 2 different, okay. Question number 4. This parabola is a little strange. Wait. Question number 4. If you have this little Question number 4. We have another wonky graph, but nothing's too wonky for banana. Okay, bro. Question number 4. We got this pretty interesting looking graph, so I'll plot the points again in which the graph changes direction, and I'll do what I've always been doing, reading the graph from left to right. Here I can tell that it's been going up for a while, so I'll put infinity up to 0, because again we do use the x-axis, not the y-axis. But since there's 3 different times that this graph changes, I'll have to plot 3 different answers that add up to the same question. So again, we can tell there is a decrease in this function. The intervals being 0, which is where we left off, up to 2. Finally, leaving off at 2, you see how the graph increases infinitely forever, so we just plot that as our answer. Also sharing where it's going specifically. Woo! Question number 5. This is the last question of the day. Banana and Joe's going to plot our point of change again, and we're going to highlight it. So we see it's actually kind of similar to the parabola here at number 1. So we'll just knock this out. We'll start with infinity up until what seems to be 0. And then, again, starting up where we left off, 0 onto, you guessed it, negative infinity. Now, you might be thinking, yeah, it's going down, but wouldn't it stay constant because of the horizontal asymptote? No. It's going up forever, up until 0 at least, and then it's going down forever, starting from 0. Since it can't actually touch the horizontal asymptote, it's going to keep going down slowly but surely, but it won't exactly hit 0. Banana Joe knows because Banana Joe's the GOAT. Zoom out, and that's about it. I think I taught the same thing twice. I'm gonna have so much to edit at school. Who's viewing me? Wait. Wait. Viewer? Screenshot me. Okay. Oh my gosh. I supposed to have I have a script and everything, but dude, it's hard to follow. Really hard to follow. Wait, I have to do my outro now. Bear with me. Thank you guys so much for watching my tutorial on 2.2 more on functions. I hope this helped you. Banana Joe, peeling out. Boom! What am I doing, bro? I'm in a banana costume, streaming on Twitch. Oh, I'm actually so dumb, bro. Okay, I'm gonna do this one more time. One more go, guys. This is my third time doing this, so I didn't even record that second time. Thank goodness. What is up, Banana Republic? Wait, no, I already did the intro. I need to do it. So let's peel right into it. Here we have 2.2 more on functions. So let's get straight into these functions. Here we have our first contestant, number 1. So we want to determine the intervals in which our function goes up, goes down, or remains constant. So I'm going to plot a point on the graph in which the direction of the graph actually changes. And what I like to do is use a highlighter to highlight the line in which this change happens. And so when we answer our problem, we're going to answer it with 2 different intervals, because there's 2 different sides of the graph that we have to read that has changed, the left and the right. So let's get into it. Our first answer will start with negative infinity. We can say that because the graph has appeared to go down and continue to go down up until this point, which is actually negative 2. So we'll plot that. And then for our second part of the problem, the right side, because we just plotted the left, we're going to write where we left off at negative 2, which seems to look like a line going on forever, which would be infinity. That was problem 1 of our worksheet. And then Joe's like, ooh, man, congested. But now Joe's gonna scooch on to problem number 2. We have a little wonkier graph, but again, we'll do what we've always been doing. We're gonna plot the point in which our direction on the graph changes, and we'll highlight a line down to showcase where the change is happening. I'm gonna write my answer out. So we're gonna start at infinity, because the graph appears to go up until this point of 1. You can write our right side of the graph, which starts at 1 and goes on to infinity. I say infinity because the graph is going on forever. Not up, not down, but you guessed it, constant. So we're going to write an arrow to showcase where it actually went. Oh, I just sold. Wait, I did a problem wrong. Oh my gosh. Oh, I gotta restart now. Bro, this is so embarrassing. Did I just lose 1? Bro, I just lost like 2 followers. That's okay. It's not about the followers. I do it for the love of the game. How do I? Oh. Do it. Banana Joe coming at you live with problem number 1. So we need to use these following graphs to determine the interval in which the function increases, decreases, or remains constant. How do we do that? What I like to do personally is plot the point in which the direction of the graph changes. And I also draw a line down the middle to showcase where that change is, which is at negative 2. Here, we can start plotting our answers. Starting from the left, we can determine that the graph starts at negative infinity, since it appears to keep going down forever, but not forever. It starts from forever, but it doesn't end at forever, because we're actually going to plot the second part of our answer, which is negative 2. Negative 2 on the x, or negative 2 on the y. Negative 2 on the x-axis, because the y-axis isn't what we're looking for. But now Joe wants the domain, and I hope you want it too. So now, we'll pick up where we left off at negative 2, and then move on to the right side of the graph, which appears to be infinity, because it goes on forever. Hopefully your graphs have arrows, because those are very important. Let's slip into problem number 2. We have a little wonky graph here. Wait a minute. I keep forgetting this. I'm going to edit this out. Once you finish plotting your graphs, don't forget to add the direction in which these points have gone. So we know, holy schmoly, wait a minute. I after you plotted your graphs, after you plotted your answers, you want to put the directions in which they went. So we know that it started off negative, going decrease. Oh my gosh. Bro, am I actually dumb? Bro, I don't even know what I'm teaching. So now that we found the intervals in which the graph either increases or decreases, we can now label it. So we know on the left side it was decreasing, and we know on the right side it was increasing. So I draw these arrows to show that, because you need to show your work. Banana Joe encourages you to. Now let's slip into problem number 2. Again, we graph the point in which the direction of the graph changes, and then Banana Joe starts to graph after he draws his imaginary line with a highlighter. So, reading the graph left to right, Banana Joe determines that it actually goes from infinity onto what appears to be 1. Again, we start where we left off at 1, but we actually plot, you guessed it, infinity. It's a constant, but it's constantly going forever infinity. It doesn't have to just increase forever or decrease forever. And now Banana Joe's going to label it, because I keep forgetting. This one, the first side, the left side, has been going up, and the second side has been constant. Did I just get a follower? Cheap follower? Bro. Let's ignore that comment, guys. Question number 3. Banana Joe got it real easy. We really got to plot a point. We ain't got to draw no line, because we can tell that it's been going on and will continue to go on forever. So Banana Joe only has to plot one answer, which is negative 2 onto infinity. Again, we label where exactly the graph is going, which, you guessed it, is up, increasing. It's not constant, because a constant would have to look like that, but it's increasing, but very slightly, so it looks like this. Something like that. Banana Joe is going to do 2 more problems, and then he's out skis. How are we going to do something like this? This graph. How is Banana Joe going to do a graph like... How is Banana Joe going to solve a graph like this? It moves in a lot of different directions. That's okay. Nothing I can't handle. We'll, again, plot points in which the direction changes in the graph, and then we'll solve. Since we see that there are 3 different times when the graph changes directions, we're going to plot 3 different answers. First will be not negative, but infinity up until 0. Our second point will start from 0, and then we'll move on to 2, noting that it goes down. Our last point and our last answer would start from 2 onto infinity. We can say that because it goes up, and then down, and then up again. So we can label that as increasing, decreasing, and then increasing again. Last problem of the day. Banana Joe is glad to slip into this. Here we're going to plot the direction in which the graph changes again, and then we'll answer it. It's similar to a parabola, but it's also not. So we'll start with infinity up until where it stops at about 0. And then graph the other side, which is 0, onto negative infinity. Banana Joe, wouldn't it be something else? No. You can notice that there is a horizontal asymptote on the bottom. And although it looks like it's kind of just drifting off there, it's still decreasing. Try to get ever so slightly to the 0 line. So Banana Joe says that this is actually a correct answer. Bro, I have so much editing to do, bro. I gotta use the bathroom, but I'll be right back. Gabe? I know you just called me while I was streaming. It's so good, bro. I'm so happy. You'll never know what Banana Joe's wearing.